All right, in this problem, we are given acceleration in terms of velocity. So acceleration A of t for a skydiver, which does take into account air resistance, is given as negative 9.8 plus constants k over m, where we are given that k is 21 and m is 76, times the velocity at time t squared. And the question asks, what is the object's velocity when acceleration a of t equals 0? And this velocity is the object's terminal velocity. So what we're going to do is plug in 0 for a of t and solve for v of t. All right, so if we plug in 0 for a of t, we will have 0 equals negative 9.8 plus k over m, k is 21, m is 76, times the velocity at time t all squared. I like to add extra parentheses there. Okay, and it says what is the object's velocity? So that means we are solving for v of t. All right, so we're going to add 9.8 to both sides. And I do want to get this as an exact answer before approximating here. Okay, rather than divide by the whole fraction, let's simplify a bit by multiplying by 76. So we'll need a calculator for that. We're going to do 9.8 times 76. To get 744.8 in the numerator. And then we divide both sides by 21 to get that. So that equals the velocity at time t squared. So we still are solving for velocity, so we now need to take the square root of both sides. And when you have a variable squared and you take the square root of both sides, there is a plus or minus on the other side. So we have plus or minus the square root of this fraction. And just to make it so that it doesn't have a decimal, I'm going to multiply the fraction by 10 over 10. Move the decimal over 1. Okay, so there's the exact velocity. Now, the skydiver is going down. He's falling, right? So it's a skydiver, so he is falling. When you are going down, your velocity is negative. So therefore, we're going to choose the negative one for our answer.